This is section 2.3, and we're going to do some operations on matrices. And again, we talk about that they are classified by size, and we always list the size as rows by columns. So again, looking here at this one, this is a 2 row by 2 columns, so that is a 2 by 2. And then this one is a 3 row by 1 column, so it is a 3 by 1. Two matrices are equal only if they are the same size and the corresponding elements are equal. That's important. All right, so if we are looking at these two matrices, they do have the same elements in them, but note that they are in different positions. So what we're talking about is that the element in this position has to be the same as that one. In this case, that isn't true, so these are not equal matrices. All right, so the elements have to be the same and in the same position. When you're adding matrices, and you could do it on the calculator, but sometimes it's just as quick to do it by hand as it is to take time to put it in the calculator. So you add the specific positions. So if we add 5 and -4, we do get +1, and that is our new in our sum. This is going to be that. -6 plus 6 is 0. 8 plus 8, 16. 9 minus 3 is 6. So that's how that will go when you're adding. Now, additive inverse, or the negative of a matrix. So if this is matrix A, the negative A is just the negative or the additive inverse of all those items. And if you add this type of inverse, if you add a +1 and a -1, you will get zeros in everything. When you're adding and subtracting, they must be exactly the same size. So you could not add a 2 by 3 and a 3 by 1. They must be exactly the same size. So I think that's the items that we need to talk about in the notes. Let's look at the problems for 2.3. All right, first question says, decide whether the statement is true or false, and if it's false, tell why. So we've got this matrix equals this one only if x equals 1 and y equals 3. Well, that would be true, because then you would have 1, 3 equals 1, 3. So we just choose 2. That one's easy enough. Find the size of the matrix. Determine if it's a square, a column, or a row matrix. All right. This is a square. It is 3 rows by 3 columns. So it's 3 by 3, and it is square. Number 3, determine the size of the matrix. Well, the size of the matrix, how many rows do we have? 4, 1 column. So we have a 4 by 1. Find the values of the variables for which the statement is true. So we've got some little tiny equations in here. So the top row, we've got x plus 1, we've got y minus 4, and then we've got some on the bottom row. For it to be equal to this one right here, then we need to take x plus 1 and set it equal to -1 and solve for x. When you do that, you get x has to be -2. That's the only way that makes this a true statement of equality. Do the same thing with the second one. Y minus 4 has to equal 5. So y has to be 9. So you go through and do that with each of them. Fill in for each variable here. That should be pretty simple. Add the following matrices. Well, what did we say? We said they had to be exactly the same size. This is a 2 by 3. This is a 3 by 2. The matrices cannot be added. So be sure you're not trying to do something when it's not even allowed. Number 6. All right, we've got adding these two matrices, and then we're supposed to subtract that one. So I did this in 2 parts. Add these two, you get 12, 15, 5, 12. Then subtract this one here. So 12 minus 4 is 8, 15 minus 1 is 14, etc. And this will be your answer. So you put those numbers in your answer boxes. Number 7 is very similar. You've got a subtraction and then an addition. I would do it in 2 steps. Subtract those two, get this, then add the second part here, and you get your final answer. Okay. Number 8. A toy company has plants in Boston, Chicago, and Seattle that manufacture toy phones and calculators. The matrix gives the production cost in dollars for each item. So it costs $4.69 in material and $3.58 in labor to make a phone, and $6.58 and $3.84 for calculators. Now, it says in Chicago, a phone costs $4.44 for material and $6.04 for labor, and $3.43 for material and $3.83 for labor for a calculator. So this is the production cost matrix for Chicago. So $4.44, $6.04, because that's material and labor, and then for the calculator, $3.43 and $3.83. Suppose labor costs increase by 14 cents per item in Chicago and material costs increase by 34 cents for a phone and 45 cents for a calculator. What's the new cost? So $4.44 plus 14, I said that wrong, I'm sorry, because this is material here and labor. So the labor is increasing by 14, so we're going to add 14 to both of these. So we get $6.18 and $3.97. And then the 34 gets added to this one because this is the phone. And 45 is getting added to this one because that's the calculator. And you end up with your new matrix. All right, this one's kind of long, but really quite simple. A dietitian prepares a diet specifying the amounts a patient should eat of the 4 basic food groups. Group 1 is meats, Group 2 is fruits and vegetable, Group 3 is bread and starches, and Group 4 is milk. All right? And amounts are given in exchanges that represent 1 ounce of meat, 1/2 cup of fruit and vegetable, a slice of bread, 8 ounces of milk. So, the number of exchanges for breakfast for each of the groups respectively are, and it gives you the numbers. So if you want to think about it, and it asks you to write a 3x4 matrix. So you know it's not this one. This is a 4x3. So we know we're going here, and it said for breakfast, 1121. So 1121. For lunch, 2321, and for dinner, 4221. All right? The amounts of fat, carbohydrates, and protein in each food group are. So they got 6, 1, 1, 6. Carbohydrates, 1, 16, 19, 14. And protein, 5, 1, 2, 7. And these are the 4 food groups. Group 1, 2, 3, 4. There are 5 calories per exchange of fat, 4 per carbohydrate, and 7 per exchange of protein. Summarize this in a 3x1 matrix. This is the 3x1, 5, 4, 7. So it's really just giving you some material and getting you used to putting it into a matrix. Number 10. This is the death rates for male and female drivers for various ages and number of passengers. And so number A says write a matrix A for the death rate of male drivers. So we're just going to take this part here and put it into a matrix. Okay. B says for female. We did the same thing here for female and put them here. The last part says use the matrices from A and B to write a matrix showing the difference between the death rates of males and females. So you're literally just subtracting. And I didn't put all of them here, but you get the idea. 267 minus 146 is 121. 441 minus 171 is 270. So you're just subtracting the positions that match, and you should be able to do that one. So I think that'll get you going on 2-3.